Now, getting to zero these days usually means heat pump water heaters. The Rheem Prestige is what your clients need. Different setups for cold, warm weather climates, the highest efficiency, quiet operations, and leak detection through smartphone technology. And also a huge thanks to our main sponsor, Mitsubishi Electric. Mitsubishi provides all your heating, cooling, and filtration needs all in one system. Today's low-load homes require right-sized equipment, and most systems, especially gas-fired ones, cannot meet the challenge. Mitsubishi has low-load, high-efficient heat pumps that dehumidify and cool in summer and work in reverse in the winter. Going ductless reduces costs and makes it easier to meet Energy Star version 3 and the LEED for Home certification. Ductless mini splits can now be hidden in many different ways to meet your client's needs, and ducted systems can now be used as well, retrofitted right in. Out of sight, out of mind, all the comfort, but none of the thought for your clients. Hyperheat ensures an efficient heat delivery down to negative 13 degrees, and backup strip heaters kick in during the rare but coldest of cold days. Each room of a house can customize comfort while still being all electric and energy efficient for clients with different needs, and only heat or cool rooms that actually need it. Multifamily commercial centralized variable refrigerant flow or VRF systems work great on larger projects looking to serve whole buildings. VRF heat recovery technology permits for simultaneous cooling and heating. As this illustration depicts, a space can have many purposely designed areas, each area requiring a different cooling or heating need depending on the day. Check out Mitsubishi Comfort today for all your HVAC needs. All right, well, welcome to How to Design and Build Affordable Zero Energy Homes. This course, the proof for 1 hour in continuing education units, GBCI, NARI, Green, AIBD, CPI, NonWholeHouse, as well as AIA, Health, Welfare, and Safety, which may make it applicable to your state-based designer contractor license. Today I'll be your moderator. My name is Brett Little. I'm the executive director here at the nonprofit, the GreenHome Institute. Now today we're going to be asking the question, trying to answer it, is zero energy new construction really not affordable anymore? Can it be done easily and cost effective? And that's the kind of question we want to answer here and that we continue to answer because we think it's very important. So I'm very excited to introduce you to Bruce Sullivan. He's been helping people save energy for 35 years, longer than me, as a program specialist, trainer, writer, and consultant. He was a senior green building consultant at Earth Advantage for 7 years and is also a consultant with Zero Energy Projects. He has lived in a series of efficient homes. 3 of these were state-of-the-art energy-efficient new construction projects he helped design and build. I'm very jealous. And the most recent of these homes generates enough energy on-site to run the home and power and electric costs. Plus, it costs about $8 a month or less to own than a similar conventional house that would have had higher costs. So, Bruce, we're very excited to have you here today, and please take it away.
Well, thanks a lot, Brett. I really appreciate the opportunity to speak to you and your members. And welcome, everybody, to this GreenHome Institute webinar. We're going to talk today about how to design and build affordable zero-energy homes. Just to kind of circle back a little bit, we've been working on zero energy for many years, but didn't know it. In the early years, I think that we were accepting incremental improvements in energy efficiency, a little bit here, a little bit there, and finally we've accomplished something. We're getting within striking distance, I think, of making homes truly zero energy or zero carbon, depending on how you want to phrase that. And I think that the technology is all there. I mean, when I looked at the list of attendees this morning, Brett sent me a copy of the list, and I see some very able and distinguished and knowledgeable people on that list. A lot of the things that I'm going to talk to you today about might seem a little like a rehash, but I think what we're trying to do is to spin this a little bit toward the idea of affordability. We all know that the technology exists to build zero energy homes today, and the biggest barriers are really the financial barriers. So what I'm going to try to do today is to talk about some of the sorry, I'm struggling with it. Here we go. Talk about some of the different issues that we can do to kind of make things a little bit a little bit more financially affordable for the people that want to do it and really make them available to everyone. And that's kind of the purpose of my work with the Zero Energy Project, is to make zero energy homes affordable and so affordable that they are really mainstream. We spread the word about zero energy buildings to builders and home buyers and real estate brokers, and we're trying to really reduce the carbon impact of all buildings. But my background is really in residential, so that's what that's what I'm going to be talking about today, is more residential buildings, but many of the principles, of course, apply to larger commercial buildings as well. Today, we'll basically talk about affordability. We have to just, cover all the bases, I think, and start about just a short description of what is net zero. I tend to use the terminology of a zero energy building just because I'm tired of saying net all the time. Zero energy, net zero, zero net, all those things to me mean the same thing. And I suppose that we're now starting to even think about these homes more as zero carbon buildings, and that's perfectly acceptable as well. So we'll also talk a little bit about the elements of zero energy home. Again, most of you, I think, are familiar with and do work daily with these technologies. I won't really describe them in great detail, except my angle on this is really going to be which systems and materials and techniques are going to be the most affordable. And finally, we're going to end up talking about what I think is the real key here, and that's the financing side of this. Just to reiterate what you probably already know, that about half of the carbon emissions globally come from buildings. Another third come from transportation, and taken together, those two things are what we're really talking about. We can't talk strictly about buildings, but we have to start including the location of those buildings and how it affects the transportation as well. My comments today are really going to be focused only on the building itself. I'd also like to emphasize that when we design or build something, we want it to last for a long time, maybe even 100 years. And by doing so, we have to make a commitment to society that we are going to provide the resources that building will consume over that time. So if you build a substandard building, what I will call a substandard building is one that consumes resources, then we're encumbering society for the life of that building to provide those resources. Instead, I think the responsible way to approach this is to design and build buildings that really contribute more than they consume. It's also important to remember that climate makes a big difference in how we design and build these structures, and that a house in Miami is going to be a lot different than one in Minneapolis. So that has to factor in. And really I think the key here will be to make the building, design the building it's appropriate for the climate that it's in. I happen to be in Oregon. And in Oregon, a typical house will use the equivalent of about 29,000 kilowatt hours a year. If you wanted to make that home a zero energy home, you'd probably need to put quite a few solar panels up there. Wouldn't really even fit on the roof. So the key that we've always talked about with designing and building homes is this kind of idea of a pyramid, where you focus on the shell of the building, insulation and air sealing. You put in some really great windows. You add some highly efficient mechanical equipment for space heating, space cooling, water heating, etc. And that means that at the top of this pyramid, the amount of renewable energy that you need to put on the building will be a lot less. And traditionally, and up until the last few years, the renewable portion has been the most expensive. And I think it probably is still the most expensive single component. But the prices of solar panels especially have come down to the point where some builders have chosen to turn this pyramid on its head. And in other words, they're saying, I'm going to fill my roof with solar panels and then build a structure that uses only as much energy as I can produce on the roof of the building. Now, I don't think that's the least cost path, but I think we need to kind of acknowledge that we've come to a place where some builders may choose to do that. And so it just gives us another option, really. The way to make that determination, the way to kind of figure out how to optimize these different components of the building is to use an energy model. All of you are very familiar with this. An energy model, something like Energy 10, or that's an old program, REM rate, BOPT, and some of the other energy models can actually predict the energy needs for a specific location, a specific climate, and then you use those estimates to figure out how much energy you need to produce. Most of the energy modeling up to now has been targeted really at program compliance. You know, you need to have a HERS rating to get an ENERGY STAR certification. But you can also use energy modeling to economically optimize the design. And this optimization involves doing some what-if analysis. What if I have a little bit different window? What if I have a little bit different heating season performance factor on my heat pump? So I really encourage people to take the energy modeling step a little bit further and use that tool as an economic, to use that tool as a way to really dial in the economics of the building. One thing that you'll find with energy modeling, of course, is that the shape of the building, the size of the building has some impact on the energy use. More compact designs also are cheaper to build. So it's not only a matter of size and shape, but also of the number of corners you have. I suppose that a sphere would be the most efficient in terms of surface to volume ratio. I don't think we should all be in spheres or geodesic domes, but at least keeping the number of corners down in a building is going to increase the energy performance, and it's also going to make that building more affordable. So keeping simple shapes is really a good starting point on affordability. I really want to make a distinction between efficiency and consumption. Efficiency is the use of energy per unit of something else. So we talk about kilowatt hours per square foot. When we really dig into zero energy construction, we don't care so much about efficiency as we do about raw consumption. It's not kilowatt hours per square foot, it's kilowatt hours. And so one way to illustrate this is with a little project that I did a few years ago. I participated in this life cycle assessment research, and we did dozens and dozens of energy runs on energy modeling runs on different size and shapes of homes. And this was an interesting result of what came out of that, is that you can build a home a little bit smaller and it uses less energy than an ENERGY STAR home built to a higher standard. So in this case, we modeled some conventional homes built to the code at that time, and they came out to be more efficient than a home that was an ENERGY STAR home. So I think that illustrates this idea that we really care mostly about the number of BTUs, the number of kilowatt hours that a building uses, not about some efficiency rating. Another thing I'd like to suggest about affordability is that sometimes you need to keep things simple, especially if you're asking your trades or suppliers to do something a little different. It's always going to cost more for them to learn to do something different. So kind of stick with the conventional as much as you can. Now, we're always talking about zero energy. In zero energy construction, we're always talking about doing a few things differently, but I guess what I'm suggesting is we have to keep those to a minimum so that when we are talking about something different, it's a little easier for these people to grasp it, and a little bit easier for you to stay on top of it as a project manager. And I think that one of the things that I encourage people to do is to really kind of stick with wood frame construction, because that's something that's well known. SIPS panels and ice and insulating concrete forms, they're great systems. They have lots of advantages, but generally when you do a comparable bid, you could find that those systems are a little bit more expensive. And I do encourage you to get bids, by the way. And I think this situation could change, especially as labor becomes more expensive and time becomes more of an issue, that some of the proprietary systems really might start to pencil out a little bit better in comparison to wood frame construction. But you know, overall, in terms of many of the different elements of the building, try to not put the burden of learning on your trades and suppliers as much as you can. Never forget what's inside and what's outside of the building. Unfortunately, an attic space, a ventilated attic, is outside, and a ventilated crawl space is outside. Most garages are outside the building, and yet this is where conventionally people put their heating and cooling systems. So we don't want to really do that. We need to bring the heating and cooling systems within the thermal boundary as much as possible, and that'll make a big difference right there. It's probably, you know, in terms of percentage savings, you know, maybe 20 to 30% savings just by pulling the mechanical system inside. We'll talk more about this in a minute. Also, in terms of design, try to take advantage of the site. Use south-facing glass as much as possible. What this will do, of course, is it improves the heating performance in the winter, but it also reduces the overheating problem in the summertime, at least in the northern hemisphere. And this is free. It doesn't cost the designer anything to start the design with these principles in mind. So there's a great way to save energy and eliminate costs is to use this kind of sun tempering idea. I know it doesn't apply to every site, but where it does apply, it really makes a lot of sense to use it. All of these different ideas about energy efficient construction and zero energy construction require that we do things a little bit different. It's very much of a process-oriented thing. The builders that have successfully incorporated passive house standards or zero energy standards into their projects and do it consistently tend to rely on a checklist that will allow them to express their clear expectations to the trades and the suppliers, and even their own in-house people to check things off and make sure at every stage of construction the things that need to get done are done. So I highly encourage people to use this kind of, take this collaboration and process thing seriously. This applies to your scope of work, for example. If you expect something from a trade or a subcontractor, make sure that that scope of work is attached to the contract so that everything is really clear up front. In the efficient shell, obviously more insulation is always needed, but the way to get that insulation has been subject of some debate. And in my thinking, there are two probably equally good ways to get an affordable building shell, and that's either to use an exterior insulating sheathing or to build double stud walls. And this is almost a matter of, I think, personal preference as to which way you think makes the most sense. They both have pros and cons in terms of space utilization. Perhaps cost can be equivalent, or one is a little bit better than the other. But I think they both work really well, and it's almost a matter of which way your analysis points you to choose which of these different options you should follow. So, you know, in my mind, there really isn't much of a difference. It's mostly just something that's a personal preference. In either case, however, anytime you put insulation in a cavity, I believe it should be blown-in insulation, and that is because the greater density of the fiberglass or cellulose insulation will give you a little bit better R value, but it also has some beneficial effects on air leakage, and so blow-in insulation, to my mind, is a really good place to put a little bit of extra money in order to get that good performance. Air sealing, of course, is another element that's a lot of people spend a lot of time and effort to do. You can have exterior sheathing sealing systems. In my particular case, the builders that we used, and we used the sheathing, exterior sheathing as the air barrier. We glued it in place onto the framing, and that worked out really well. I mean, you can use a proprietary system like zip sheathing, but in any case, there's just a lot of little details that have to be addressed. In some of the tapes, I think, are also useful in many cases. But there's a new player in the market too that I'm sure you've heard of, and it's called AeroBarrier. AeroBarrier is a kind of an aerosol sealing. It's a mist that's used in the house. The home is pressurized with a blower door. It's not doing an air leakage test, so it's not depressurizing. It's blowing air into the house, and so therefore the air that leaks out of the house carries this mist with it. And as the mist flows out through the openings, it will start to accumulate on the edges of these openings, and that seals up the cracks. You can see in the lower right-hand corner the kind of before and after of a crack between two pieces of framing. What's nice about the idea of AeroBarrier is that most of the responsibility for air sealing falls on a single subcontractor, and that subcontractor can virtually dial in a specific level of air tightness. So if you pay them to get to 3 air changes per hour, that's what you'll get. If you want to go down to passive house, 0.6 air changes per hour, you can get that, and you'll pay accordingly, of course, but there's no guesswork. I mean, so often, if you do all this air sealing in the conventional way with all the little bits and pieces of the building, and then you're kind of fretting on whether or not what's your blower door test result going to be like. So with AeroBarrier, I think it takes some of that guesswork out of it, and you can hit a target fairly consistently. It's a new product. I don't know what the pricing is like yet, but I think that's something that deserves some consideration as you're putting together your budget. Spray foam has often been talked about as a super duper insulation and air sealing method. It's got some advantages there. It also has the disadvantage of at least the closed cell spray foams are a greenhouse gas, have a greenhouse gas problem. There's a global warming potential for closed cell spray foam that's quite high. This information has been out for quite a while, but I wanted to point out that closed cell spray foam, there is kind of a new blowing agent on the market now. It's been out for a while called Solstice. It's made by Honeywell, and it can address this global warming potential. The one disadvantage of air sealing with spray foams of all kinds. Oh, I should mention too that some of the water-blown foams don't have the global warming potential either. However, they really don't give you much of an R-value advantage over fibrous insulation. So one of the disadvantages of any of the spray foams will be that it doesn't really address some of the cracks. For example, where framing is ganged up, you often have to go back and pick up some of those little spaces that the spray foam doesn't cover. So it doesn't take care of just about everything. Windows, how do you address windows? Well, the first thing again is to orient most of your window area to the south. That's kind of a freebie, kind of a design feature. The other thing I kind of question is the need to do the super duper European style triple glazed windows, especially from an affordability standpoint. Maybe the best double glazed window that you can find it will be good enough. And that's something that definitely is going to affect your budget by sticking with a more conventional window. Some ways to offset the extra heat loss you get through the windows would be to think about reducing the amount of glazing area. We generally express glazing area in a home as being a ratio of the window area to the floor area. So that WFA ratio in a say custom home might be 30 or 40%. It's a huge number of windows. In a production home, the window to floor area ratio may come in somewhere in the low 20s. And I think that at one time, Energy Star had an upper limit of the window to floor area ratio of about 21%. In the house that we built here, our window to floor area ratio is 16%. And I think that we've been able to do that without significantly compromising the values that the windows bring. The windows are important for light, views, egress, and other benefits. And you can, again, putting some really good thought into where the placement of those windows is, how big they are, the shape of the window can bring those values to you without with a less window area. I think that's a really important concept. Not only does it reduce the heat loss and heat gain through the glazing, but it also costs a lot less money. Windows cost less than walls, so, I'm sorry, windows cost more than walls, so by reducing window area, you are also saving money. Another way to use design to compensate for a lower glazing area is to share light within the building. Transoms, doors with glass lights in them, and other methods of kind of getting light to penetrate deeper into the building can be used to, again, offset this, this reduced window area. Efficient space heating is essential, and for most of these very small homes, if they are small, ductless heat pumps are a really appropriate heating solution. They are variable speed, they are very efficient, they work to very low outdoor temperatures. In our area, the temperature will regularly get below 0, and the ductless heat pump has been working just fine. So it's not a problem as far as that. The one issue with ductless heat pumps has been distribution. And so some of the multi-head systems can solve that problem. The other thing that we can do is use small transfer fans, a small ducted inline fan to move conditioned air from a space that has a ductless heat pump head to a room that maybe doesn't have that head. There's been some work done along those lines, and seems to be working pretty well. So there are some ways to do this in homes that can get the distribution that you need. Some people will decide to stick with a forced air system, and that's perfectly fine. But if you want to make it a zero energy house, then it's almost essential that those ducts be inside the conditioned space. There are a variety of ways to do this, and it's not all that difficult. In fact, this can also save money as well as saving energy, but it must be a part of the design. The designer has to figure out where the registers and ducts are going to run and provide a space for that. Usually it's in a drop soffit, a drop ceiling in a hallway, or sometimes running through chases, interior chases. There's quite a bit of information out there. US DOE has some publications. There's a website called ductsinside.org that you can look at for quite a bit of information about this. But again, if you're going to try Ducts Inside, it has to start with the design. You can't allow the guy in the truck to roll up at the framed house and expect him to be able to figure out how to get ducts in there. Ventilation is essential. Good ventilation is essential. And so we do this usually with a heat recovery ventilator. That's been the standard. And I think that makes sense. The biggest value of a heat recovery ventilator or an energy recovery ventilator is really that it is giving you balanced ventilation and good distribution. And so, but it's also over the time been fairly expensive to do this. I mean, the bids that I have seen recently are anywhere between $3,000 and $4,000 for a kind of a standard heat recovery ventilator. And that's very difficult to build into an affordable budget. So some other possibilities might be a spot ERV, this fairly low flow, good for kind of meeting your ASHRAE 62.2 ventilation requirement. Doesn't give you great distribution, however. We've also seen some ductless heat recovery ventilation systems. A couple of different companies have these, and these are just kind of through the wall systems. They are great for smaller homes. In larger homes, the cost kind of adds up, and you need to have several of these units to serve different rooms. So there's a cost issue there. I'd like to suggest that we basically get rid of the heat recovery and just stick with the good distributed balanced ventilation and not incur the cost of heat recovery. This might be a good option for affordable homes. I learned just recently that the ventilation cost for in most of North America is about $2 per CFM per year, and at that rate, to meet your ASHRAE 62.2 target, the value of the energy that you're saving is only a few $100s a year. Maybe it doesn't justify the high cost of heat recovery, elaborate heat recovery ventilation systems. Some people are going to be a little upset with that statement, but I think we really need to kind of tone down the cost of ventilation to make it fit this affordable target. Water heating, again, is essential. Brett mentioned earlier that efficient water heating in a zero energy home probably means a heat pump water heater, and those are great systems. We don't really see people doing the old-fashioned thermal solar water heater anymore. Now it's an electric heat pump water heater with a couple of extra solar panels on the roof. And that's been working out really well. The issue, of course, is that the heat pump water heater will chill the space that it sits in. And so in climates that are heating dominated, you generally want to put those systems into garages or basements that are buffered spaces, that aren't principally heated. Another way to do that is to duct these heat pump water heaters. Most of them come with a duct kit, allowing you to draw air from one location and expel the cold air to another location. So that's another thing to really keep in mind. There's also a new player around that you've probably heard of. It's a water heater, a heat pump water heater that has an outdoor unit, much like a ductless mini split. That outdoor unit then doesn't have any effect on the temperatures of the indoor air. There's no kind of parasitic loss of energy inside the building. And so the heat pump works really well. They've been tested in extremely cold climates. And one of the nice things too is that they don't use a halogenated fluorocarbon type of refrigerant. Instead, they use carbon dioxide as a refrigerant, and that means that if the refrigerant leaks out, it's got a much lower global warming potential. It's also possible that you could essentially use a standard electric water heater. You get a standard electric water heater. It's got an energy factor of about 0.94, 0.95, and then just add additional solar panels to make up for the difference. So instead of adding 2 or 3 panels for a heat pump water heater, you might have to add 6 panels. And I can't say that this is the best way to go, but I can say that it's probably worth considering and pricing out for your particular project at the cost of installing solar in your area. So, I guess the nice thing that helps with this a little bit is that we still have some fairly attractive tax credits and utility incentives around solar panels. So if you're adding more solar panels to your project, those the cost of those can be a little bit lower. Lights and appliances are, of course, something that we want to keep an eye on. All of the bulbs should be LED bulbs, but I encourage you to pick carefully, think through the quality of the LED, because you're going to live with those things probably for as long as you're in the house. You'll move out of that house before you have to change that light bulb. So pick one that's going to have adequate illumination as measured in lumens. So if you want a standard lamp, maybe that's 800 lumens, but if you have a location that you generally put in a little bit bigger, higher wattage incandescent bulb, think about an LED that's maybe 1,000 or 1,200 lumens. Also consider the color temperature, whether it's a warm kind of yellowish to orange light or a cool bluer light. And don't forget to check those features on the package when you buy those lamps. Again, you're going to live with that LED for a long time, so be sure that it's the one you like. When you choose appliances, the Energy Star label is a good place to start, but again, it's probably not going to get you the most efficient appliances. Fortunately, the Energy Star website also does have a ranking of the most efficient appliances in every category. You can go to that page and kind of keep your selection toward the top of that page to get the best appliances. One of the last reasons that people need to have natural gas service in their house is for cooking, and a lot of people just think that cooking on electric is not possible, but that's starting to change now that we have induction cooktops at a more affordable level. One way to reduce the amount of cost that you're assigning to your induction cooker is to use fewer, I don't know what to call them, use fewer hot spots. They're not really burners anymore, but so whatever that thing is that on the induction cooktop that makes heat, you can use 2 instead of 4, and that'll really shave your cost quite a lot. The other thing that's nice about induction is that you can buy little countertop models, and so say that you only think you need to have 3 units on occasion, maybe for big parties or events, then you can keep the 3rd one in the cupboard and pull it out only as it's necessary. That not only saves money, but saves some counter space. Entertainment is turning out to be one of the big energy users in a house. Don't forget that your big screen television, your cable box, or your game console is also using a lot of energy, and look for the energy consumption of those items when you upgrade. Overall, all of these different issues are focused on kind of one thing, and that is that you want to put your effort and money into the structure and function of the building and leave some of the cosmetics for later. Countertops, cabinets, carpets, some of those things will inevitably be changed, and so you can shift some of your budget into the structure and function and leave some of the cosmetic things for later, and when you can kind of fill those in. Again, those things are going to change anyway, so maybe it makes sense to kind of go save some money on the finishes and put your money into the structure and function of the building. Of course, the last step, the top of the pyramid, is an on-site renewable generation, and so that's something that's changed quite a bit. Solar panels are a lot cheaper than they used to be. We now have options for off-site generation too, with community solar programs and in utilities renewable energy programs that you could decide will fit you if you don't have good access to the sun, or you don't have the budget to put the solar system in right away. Maybe those off-site programs can help move us generally toward zero energy. So when we put our house together in 2015, it turned out something like this. It's a small house, 900 square feet. We spent about 40% less money on construction than would be typical in our area. It's not all that extravagant, really. The walls are R40 walls. That's a double stud wall with 10 inches of blown fiberglass. We also used blow-in fiberglass in the floor. That's a 2x12 I-joist, a 12-inch I-joist. And the windows were the best double-glazed windows we could get. Spent a lot of time on air sealing and got it down to 1 air change per hour. The ductless heat pump has an HSPF of 13.5, and there's a heat pump water heater, and we could run all of that with a 4.3 kilowatt solar system. So it turned out to really work, I think, quite well. And we actually ended up having more energy available than we could use in the house. So we went out and bought ourselves a used Nissan Leaf, and we've been able to charge that up over the course of this year without going over our energy production. So we'll see how that works out in the future. We might end up having to buy a little bit of electricity from the utility, but so far we've been able to run that car without it. One thing you can really do to help manage all this information is to engage with a third-party certification program. And a lot of people say, well, I don't really need the certification, but you get a lot more than just a piece of paper from these. You really get a lot of technical assistance from your energy rater. All of these systems require some kind of an energy model, so that'll engage or get you connected to a person who can do your energy modeling. And these raters and professionals really have a lot of experience from working with these high performance homes, and so they can really help you out with your project. Some people are concerned about connecting to the grid. We used to hear more of this, but a lot of folks like to say, I'm going to go off the grid. Well, I think the grid is our friend, and we really need to be connected to it so we can share the excess energy when we have it and then draw from the grid when we don't. It really prevents the need for us to have some kind of battery storage on site, and that's pretty important. When you start planning for your zero energy project, be sure to contact the electric utility that serves the site, because they're going to have a net metering policy, and these policies vary widely around the country. So it's important to understand exactly what benefits you'll get from your net metering policy and plan your project accordingly. In many cases, you are credited for kilowatt hours that you generate in excess of what you use, and then you have some time in order to use those credits. In my case, we accumulate credits over the summer. We can use them in the winter, but then in the spring, our account is zeroed out so that we have to start over with the accumulation. In that kind of a net metering system, we're essentially getting the retail value of the electricity that we generate. If in other cases, you may not get the retail value, and in that case, you may want to consider some kind of an on-site storage system, such as a Tesla Powerwall, but there are lots of other different battery manufacturers that are making these household systems. Sonnen is one, Mercedes is another, and so, you know, you can really take advantage of the storage in order to make up for a net metering policy that may not be as advantageous as you want. Of course, the utility can also use the same technology to store energy in the grid, and I think you're going to see a lot more of this happening. So if you're faced with criticism that the electricity that you're generating on your roof is somehow a detriment to the grid, I think that's going to be a very short-lived situation if it was ever true to begin with. One way to save money on your project is just to build the shell of the building, but hold off on the solar panels. Again, since the solar panels seem to be one of the biggest single expenses, maybe deferring those would be a way to save a little bit of money in your project. And that certainly makes a lot of sense. If you can build the shell of the building just the way you normally would, and then leave a place for the solar panels on the roof, make sure the building is oriented correctly, maybe even run some conduit to the roof area for future connection. The downside of solar ready, though, is that the incentives for solar panels are pretty nice right now, and as solar panels have become cheaper, some of the utility incentives have declined. Some of the tax credits are going to start declining now, including the federal tax credits. So it might be a better time to buy the solar panels now if you're counting on getting those financial incentives. So you put all this together, and I don't want to forget, since we're talking about money, we don't want to forget that there are other great reasons to live in a high-performance zero-energy building. There's great comfort. The indoor air quality is better than a conventional house because the people that put these homes together are paying better attention to air quality. And they're quieter, and obviously you don't have any cost for energy going forward, and you're not subject to the price escalation that is inevitable in the future. So let's talk a little bit now about the financial side of this. The projects that we talk to people about, especially, you know, this is probably on the lower end of things, but the projects that we're talking to are costing folks about 5 to 10% more than a conventional home up front. And that's something that we can work on, but there is always going to be some added upfront cost. And I think the issue is really, how do you manage that extra cost? Well, let's look at the cost of ownership. The total cost of ownership on a monthly basis could be based on typically, you know, a lender might look at principal, interest, taxes, insurance. But if you include energy in that monthly cost, then it changes the situation quite a lot. It's really unfortunate that we don't include energy in our monthly costs, because we get that bill every month just like we get a tax bill or an insurance bill, or we have to pay our mortgage. So when you include energy in the calculation, now you can actually see that a house, even though it costs more to build, it costs the same amount on a monthly basis to live in that house. And that simply happens because you're shifting money from the energy portion of your monthly expenses into the principal and interest portion of your monthly expenses. The average home owner in the United States spends about $2,200 a year on energy. That's $183 a month. We know that for every additional $10 in income, you're eligible for $2,000 more in a mortgage. And so essentially this is the buying power, the money that you're spending on energy. If you move that over into your financing, you're going to be able to buy more house. So this is one way that you can finance that upfront cost. And if you work out these numbers for this example, the homeowner could basically afford to invest another $36,000 in their home. And for a lot of homes, that's enough to make it zero energy right there. Now, every house is going to be different, and the energy cost in different parts of the country is different. So this kind of analysis is something that you have to work out for yourself, but you can use this same idea to figure out what kind of buying power you have by essentially turning your electricity cost to zero. Another way to look at the way to pay for the upfront cost is to just make the house a little smaller. So let's look at this example here. We're going to focus on 3 columns in this chart: the size, the conventional cost, and the total zero energy cost. So let's say that you were building a 2,400 square foot house. It's going to cost you about $480,000 at $200 a square foot. Now, if you can afford to borrow $480,000, how would you make that house into a zero energy house? Well, you would look over in this zero energy cost column, come up with $480,000, and then look back to the left to the size column, and you can see that by reducing the house 400 square feet, you can basically pay the entire cost of the zero energy home. If you're able to live more modestly, starting with an 1,800 square foot house, $360,000, and by shifting that house smaller, you can maybe get by with a 1,500 square foot house and still pay for it with the financing that you've already qualified for. So this is just an illustration of how you can make this work by essentially making the house smaller. If you're building a custom home, you have some control over this. Well, you have complete control over this. If you're buying a home on the market, you may not have control over this, and the builder is going to determine what kind of homes they're building along this street, and you're expected to buy it. This is where I really encourage people to start making some noise about what it is they want. If you don't need a 2,400 square foot house, then tell the builders this, and I think they might start to respond to that kind of consumer pressure. Now, that was a very kind of static, simplistic model, and you're probably saying, well, what about cost per square foot and all this other? Well, if you're interested in kind of playing with this idea and using your own numbers, I put together this spreadsheet that allows you to kind of plug in your own examples and see how it works out. So if you're interested in playing around with this, send me an email. My email address will be in the last slide, and you can, I'll give you the URL and permission to use this spreadsheet, and you can kind of check it out. Of course, that was all very optimistic, because we say, oh, well, if just because you can afford to buy more energy efficiency doesn't mean the lender is going to give you the money. And this has been the biggest sticking point over the decades that I've been involved in this field, is that lenders refusing to acknowledge the extra value of energy savings and allowing people to borrow money for energy efficiency specifically, or for energy efficient houses. That hopefully is starting to change with 2 different things that are happening. Energy efficient mortgages have been around since the 70s, very little used in the mortgage industry. But Fannie Mae has a new program called Home Style Lending. This is specifically for energy improvements on existing homes or new homes. And so they kind of get the idea of freeing up a monthly budget to pay for your improvement loans. Property assessed clean energy loans are available in maybe a dozen states, 20 states for commercial buildings, and in only 2 states now for residential buildings. That's California and and Missouri. So with a PACE loan, you can fund 100% of any energy improvement, including for an existing home or a new home. And I won't go into details about how that works, but kind of look that up. And this is another way to kind of overcome this financing barrier. But convincing your lender, your regular mortgage lender, is probably the best way to do that. And in order to do that, you have to have an appraisal that recognizes the value in that house. So here are some tips for getting the appraisal to play out. I wanted to start with one thing that's not even on the list, and that is find an appraiser that has been trained in energy efficiency. The Appraisal Institute, as well as some local nonprofits, have certification programs for appraisers to help them understand how to go through this process. So find a certified appraiser. In fact, you can insist on a certified appraiser when you apply for a loan from your mortgage lender. And I think that if they don't give you a certified appraiser who is qualified to appraise the type of property that you have, you can contest the value of the appraisal on that basis. Also, find a copy of the Appraisal Institute's Energy Addendum. This is a form that you add to the lending package, the application form, and it will specify all the energy efficient measures, the costs of those measures. That means you have to track the cost. You need to know how much more you're paying for a high performance heating system, how much more you're paying for insulation, the solar panels, of course. So those things are important to know. Use your third-party rating, your energy performance score, your HERS rating, Energy Star, whatever it is, and attach the documentation for that third-party certification. And I really encourage you to write a detailed narrative of what the home has that's different than a conventional home, why that's important to you, and how you feel that that affects the value of the home. That detailed narrative can be very persuasive. Finally, take this whole packet and make 3 copies of it. Make a copy for your loan application to the lender. The second copy is going to go to your appraiser because the lender is unlikely to give the appraiser the packet. So you're going to need to give the appraiser the packet on your own. When they show up to do an inspection of your home, then you could hand them that packet and give them a little bit of a spiel. And finally, the third copy is going to be for you, for your record, so that when you sell the home, you can have all that documentation, and this will hopefully support the price that you want to get from your home when you decide to sell it sometime down the road. So appraisals can be made to recognize the value of the energy efficiency, but it takes some effort at this point in order to make that work. We continue to hope that this is changing now and appraisers are going to be more accepting of this, but it's going to take some work from all of us to make that happen. There is some research to support the idea that additional energy efficiency also results in higher values in the market. That research is out there. There's even a national study that talked about the value of solar panels. And in this case, they said a 5,000 watt system was worth about $21,000 to the value of the home when it's sold. Finally, there are state and local tax credits, utility incentives, etc. It's really impossible to characterize those because it varies so much around the country, but you can go to the website that keeps track of those things called desireusa.org and look up your location and see kind of what things are available to you. Things are starting to change around the country. I think this is really encouraging, where we see production builders that are starting to make entire developments more energy efficient, and especially taking that all the way to zero energy. So there's New York, there's Florida, there's Arizona, California, and even in the Pacific Northwest, we have some developments. Now, this is just an example of the geographic spread, but there are literally dozens and dozens of these things happening all over the country. If you want to find a designer or a builder that can work with you, The Zero Energy Project has directories of designers and builders. If you are a professional and you want to be on this list, please go to Zero Energy Project and we can add you to these directories. We ask that you demonstrate that you have experience with a Zero Energy Project. And this is the whole idea of linking customers to professionals with the dedication and the experience to make this happen. This is not an aspirational type of directory, but one where we hope that we are showing people that actually have experience. Another thing that I'd encourage you to do at the Zero Energy Project is to look at a couple of different sources. We have, of course, tons of information, but specifically about affordability, we've been working on this for a couple of years. There's a blog that we wrote just in April of this year that includes everything that I've talked about today and actually quite a bit more. So you can get a more complete vision of what that is going to be there on that blog. And also, you can download a copy of this great book by Ann Edminster called The Zero Net Energy Primer, and it's intended for architects and designers in California, but it really does lay out a lot of great ideas for affordable zero energy homes. So I really encourage you to download those or take a look at those two resources, and then if you have questions, you can always contact us through the Zero Energy Project. You know, we often feel like we are impotent in the face of these powerful forces. We cannot swim against the stream. But I think that's wrong. We can shape the future. Each of us has a direct influence within a certain portion of the world. It's like a sphere of influence. Some people have more influence, of course, but we all have a certain amount of influence. And if we use that influence with our families, our employers, we use it to define our businesses or our communities, then we can actually make a change. So every time you buy something or sell something or design something or build something or do anything, really, you can move the world in this direction. So please, let's move the world toward a place where buildings are not a burden on the world, but a contributor to a better life. So I appreciate your time today, and thanks a lot. There's my email address, bruce@zeroenergyproject.org. I really hope that you'll contact me and ask me your questions and give me some feedback on the webinar this morning. Thanks a lot.
All right, well, thanks, Bruce. And we got a lot of questions pouring in. We got some time to answer some questions. And before we get to those questions, just a big thanks again to all of our volunteers, our board of directors, and our top-tier sponsors, Shrenergy, on-the-go battery backup solutions for camping, mobile homes, and emergency power not if, but when the grid goes down. And structurally insulated framing systems, T-Stud, most efficient wall stud assembly on the planet, and Mitsubishi Electric, all-electric HVAC air source heat pump systems. Big thanks to all of them and to all of you. So yeah, lots of questions pouring in here, Bruce. Let's try to get to as many as we can. And one of them I'm seeing right here is just the basic one, like you know, it's the Wild West, right, for defining what net zero is, what it means. We're kind of in the early adopter stage where anybody kind of gets to make that definition. So we always ask folks, you know, what does zero or net zero energy mean to you when you say it?
Well, zero energy to me means that the use phase of this building does not generate any additional carbon to the atmosphere. So that means it's generating as much energy as it's using, and that energy is all clean energy.
Great. Yeah. Well, thanks for sharing that. So, another just quick resource. I don't know if you can send the link out to everybody. We're going to have everybody. We'll have you follow up with everybody. But would you have a link to that life cycle assessment study?
Oh, great. The one from the Oregon Department of Environmental Quality?
Yeah.
Okay, cool.
Okay, yeah, we'll just remind you to have you send that out then, not a big deal. What is the range of ideal square footage for a ductless heat pump?
I don't think that there is a limit, really. I mean, if you look at, there are variable refrigerant volume systems that are working in commercial buildings. So the technology has no real limit. I mean, I think that you run into some practical issues perhaps when you get to bigger buildings, because you just have to run more refrigerant lines to all the different interior heads. So I think to me, it's more of a matter of the cost. I mean, at some point you might end up not saving quite as much money with a ductless system as you would with or a mini split system as you would with a forced air system. The other reason that you might decide to stick with a forced air system is because you need to do some really major air filtration. For example, if you're using HEPA filters or something like that, then the forced air system might lend itself to those kinds of filtration options better than a ductless system. But I don't think there's any real physical limit on the size of the building.
Great, thanks. So two questions here on maybe if you have any more extra knowledge on CO2 heat pumps. And actually, we are going to be doing a session on CO2 heat pump technology here. But I'm going to kind of merge these two together. Can CO2 heat pump water heaters be hooked up to the heat pump that is providing the heating of the home? Or is it generally a standalone system? And then the next question is, in regards to the CO2 heat pump water heater mentioned, is the storage tank on the inside?
Yes, the storage tank is on the inside. In most of our North American climates, these systems were developed in Japan, and they first really gained a lot of market acceptance in Australia, where the tanks are located outside. But around here, we generally want to put those tanks inside unless you're kind of in a tropical climate. I don't think that it makes any sense to try to combine the air source space heating heat pump with this CO2 water heating heat pump, because you just end up making it too complex. Now they do have air source heat pumps that will provide space heating and water heating and cooling and hydronic heat and that kind of thing. So those devices are already out there. If you wanted to have a kind of a one system satisfies all applications.
Great, thank you. So I'm going to tie two other questions here together. Obviously, you defined zero energy, but the question kind of is, what ends up happening with when we start to plan for zero, but then the weather just gets crazy. And then on top of that, someone said, hey, we've got this category for hurricane barreling down on us in NC, and they're saying my clients are really into resiliency. So how do you reconcile, crazy weather and resiliency with net zero?
Well, being resilient, being zero energy and being resilient there's a very large overlap between those two things. So your zero energy house can be completely resilient if it has on-site battery storage. And so if the grid goes down and you're in a place that often suffers from power interruptions, then a battery system might make sense for you, not because it's the affordable thing to do, but because it is the resilient thing to do. And so I think that there's a lot of overlap between being zero energy and being resilient. In terms of the changing climate, where we live here in Bend, Oregon, I used to say we don't need air conditioning because we have this great opportunity to do night flush cooling, where we have something like a 40-degree temperature difference between the daytime and the nighttime, even in the summer, and that is starting to change. And so now we might need cooling even in this really benign climate. And I think that speaks to the benefits of a heat pump that can provide both space heating and cooling without any additional equipment. So I think you have to anticipate that things are going to get different. I can't say that it's always going to get warmer. I mean, it might also get a lot wetter in some places. But and that could definitely affect solar insulation, the amount of energy that falls on your solar panels. But I don't think that there's any way we can predict those things. And so we just have to try to do the best we can right now and make a building that's going to need as little energy as possible to operate within these kind of affordability parameters.
On appliances, real quick, what are your thoughts about heat pump dryers or condensing dryers?
I had a condensing dryer once, a more traditional type. I didn't like it at all, and so I guess that's just a personal note. They tend to be small European models. They don't really work with an American family lifestyle very well. So I'm not a big fan of condensing dryers, but the heat pump dryer, I don't know enough about to have a strong opinion. It does make some sense to me. I mean, the idea makes a lot of sense. I just don't really have any experience or knowledge about how effective they have been or how durable they are. I have the same kind of concern about heat pump water heaters. I mean, in a sense, it's kind of like a refrigerator. It's got a compressor and things like that. So the heat pump dryer may, be able to run for 10 or 15 years without needing a lot of maintenance, but we just don't know yet. I think the other thing that's coming on the horizon, of course, is the ultrasonic dryer. I don't think we have any commercial products in the market yet, but the ultrasonic dryer uses sound waves to kind of excite the water molecules and cause them to evaporate. That seems to me to have some interesting promise.
I've never heard that. Thank you. And in defense of condensing, I will say I had one for 4 years, and I loved it. And I had a very hyper-European one 2 years before that, and it was terrible. So I'll just leave it at that.
Good.
Hi, Bruce. I'd love to hear your take on structurally insulated panels, SIPs, hybrid SIPs, and I always love to just lump in insulated concrete forms into SIP conversations.
Well, I think they're great building systems, and they have lots of advantages. And very often, people that I work with will be interested in a panelized system, and I always encourage them to take their project and send it to one of the providers, the suppliers, and get a bid. And if that bid comes in to where it works with your budget, then you'll get those extra advantages at the same cost. But if affordability is your primary concern, I suspect and will predict that the wood frame construction is going to be less affordable for an acceptable performance. Okay, you may lose some of the advantages of an ICF, for example, if you're in hurricane country and you want a concrete home that's going to withstand the storm, then wood frame is probably not as good as an ICF. But if you're not in hurricane country or in fire country, maybe a wood frame home will do just fine for lower costs. So I think it kind of comes down to that case-by-case situation. What are your needs, and what do you need, and what kind of cost, what kind of budget do you have to make that all work? But in the affordable arena, I work with a couple different affordable housing agencies, and every time we've tried to use some of these panelized systems or other proprietary systems, the costs have always come in higher. So I just can't, say that they're a good idea from a cost standpoint, despite they having some other pretty wonderful advantages.
Great, thanks. And a lot of questions pouring in here about applying your ideas here and knowledge to multifamily housing. Can you just share some general challenges or opportunities with how this could apply there?
Well, yes, I think that multifamily has some amazing potential to reach zero energy. I think we see a lot of passive house projects in multifamily. Of course, that's most of the passive house activity in Europe has been multifamily. And so I think that there is some amazing opportunity because multifamily structures are inherently more efficient than single family. So you don't have to do as much in terms of shell measures in order to reach an acceptable zero energy performance. It all comes down really, I think, to the energy model and to planning this out. We have a couple of different multifamily housing developers around here that have done, I think, good work. At least one of them has achieved a zero energy building, so that's great. And it's really a matter of kind of design and working out all these details in advance before you actually start construction. In my experience with multifamily, you also have a pretty big challenge with the implementation, because the contractors that work on a multifamily building are used to commercial scale projects where some of these details are not really taken seriously. So I do building inspections on occasion, and have found that multifamily contractors sometimes don't get the memo about proper air sealing or good quality insulation and that kind of thing. So I would say go for the low-hanging fruit in terms of the measures. Blow-in insulation is definitely worth it. Trying to get as much air sealing as you can and using really efficient equipment can make a really big difference too. So those are the keys, but you need to find a really good architect or designer to help you kind of sort through all that in the planning phase, so that, you know, once your specifications are written, it's just a matter of the contractor following those specs, which they do pretty well in those bigger projects.
Thank you. Were you measuring net zero at the site meters, or were you accounting for time of use and primary energy transmission and or storage wells?
I use the site energy definition, and the reason I do is because I think that all this talk about generation losses and transmission losses is missing the point. And here's my thinking, and don't expect everybody to agree with me, but when I generate electricity in my house, excess electricity, it goes into the grid, and it probably goes about 50 feet to the dentist's office next door. So there are no generation losses and there are no transmission losses in the energy that I'm contributing to the grid. And when the dentist next door uses the excess electrons that I produce, he is not drawing energy from the grid that is subject to transmission and generation losses. So that offsets the energy that I use from the grid that does have those. So I think that it really balances out, and therefore, as long as the energy that I'm generating is used in my local area, then I don't have to account for those other losses. So I use a site energy definition at the meter.
Great, thanks. And maybe you can share with us where the specific question here is, you know, where are you able to find U value of 0.22 double pane windows?
I think just about every manufacturer of a vinyl frame window would have something like that. So I just talk to your local window supplier and find it. I've seen things in that range, 0.22 to 0.24, in virtually every line. Okay.
Doesn't fiberglass typically have a better performance?
It does, yeah. The fiberglass are great windows. They tend to be just as expensive as wood.
Okay, that's fine.
And so, yeah, wood windows are great too, obviously. But if we're talking affordability, I'm afraid we're kind of stuck with vinyl at this point. Now, I don't think you should say stuck with vinyl, because you could make that choice within your budget. So, you know, affordability is a relative definition. It depends on the project that you're doing. So everybody has a different definition. And I think wood or fiberglass windows might fit into some people's budget.
Right. There was a question here that I'm going to have just to kind of be our last question before we wrap up. But it's kind of, if you're trying to do this and you're having trouble with your appraiser or your lender, and my answer to this is always go find a new one. But maybe, Bruce, you have a better idea or another thought on that.
No, I think that's a pretty good answer, Brett.
Yeah.
So short of just finding a different provider, I think is to be prepared. You know, really do your homework and do a couple things, and that is maybe up front select a lender. When you interview lenders, ask them specifically do they recognize energy performance as a part of their qualifying process? And so that's a good way to kind of avoid the problem of having to switch, is to essentially screen them out early on. But then you be prepared with the data to support your case. And some of the, again, the Appraisal Institute has a certification program for green appraisers. I know Earth Advantage up in Oregon has a certification program. There were probably some others around that people can use. So if you find a certified appraiser, they've at least been exposed to that information. Doesn't guarantee that you're going to get the result that you want, but it certainly improves your chances.
I was going to add to that, we're actually, we've got a whole team together and some ideas flowing on creating what we call the zero energy home mortgage. So if anybody's interested in working with us, we'll work on that anywhere we can find anyone to listen in the U.S. And you know, interestingly enough, we talked to one large lender, I'm not going to name any names, and they told me the biggest barrier to doing it had nothing to do with the appraisers and had everything to do with just their own internal system. And that if they had enough demand, they would just pay to upgrade their internal system, and they could do it, which boggled my mind because I've never heard anyone else say anything like that before. So, so anyway, we're working on it. If anybody's interested, let us know. We're just trying to find someone to work on that. So. And then, Bruce, I guess the last technical question here before we wrap up is, do you exclude plug loads from your net zero definition?
Oh no, they're probably the biggest category now. Once you've reduced the space heating and water heating, 60% of the total energy use will be plug loads. So that's where the big screen TV and the game console comes into play.
All right. Well, hey, that's all the questions I see. That's all the time we have here. Bruce Sullivan, I really appreciate your time. Thanks to the Zero Energy Project. Bruce, where can people find more information if they want to get a hold of you or learn more?
Well, they can send me an email at that address that's on the screen, or visit the Zero Energy Project. There's a comment form there. There's also a forum for starting discussions, and we encourage people to use that. So I think through the website is a really great way to get in contact with us.
All right. Well, thanks again for joining us. Thanks to all of you. Have a great rest of your week. Take care.
Okay. Bye, everybody.